Hi. So as you recall from the previous two videos with the links in the video description, I've outfitted my Heathkit Hero Jr. with a wireless transceiver called the HC12, which you can see here. It's essentially a very small module over here, which I have outfitted with a humongous antenna here. It's connected to a serial adapter. Basically it's a level shifter, and that goes via a serial cable to the back of the Junior, to the serial port over here. This Hero Junior is equipped with all the sensors. It's got a infrared motion detector, it's got a sonar, it's got a light detector, it's got a sound detector, it has a speech synthesizer, so it can speak. And I have it equipped with the Robytes multi-cart cartridge, which includes the Hero Basic cartridge. There are no internal modifications to this robot. It is essentially in original condition, so everything is really external to it via the serial port. And so the purpose of this project is to have remote monitoring and control of the robot. Currently the robot is sitting in my basement, and my hobby room is right next door, but it is a different room. We're going to be monitoring the robot's functions using a TI-994A computer. So let's go check that out. So here is the TI-994A computer, which will be controlling the Hero Jr. Wirelessly, and the wireless antenna is up here. I have it high up on a shelf for better connectivity. The Hero Jr. itself is only running a very primitive basic program which accepts input and transmits sensor data, but does not make any decisions locally at all. Everything is controlled by the TI. And we are running rich extended basic here. So the first thing the program is going to do when we run it is it's going to check for communication between the computer and the robot to make sure it's active. So that'll take a few seconds. There we are, and now we can ready to start, and off we go. The arrow indicates where the robot is facing currently, and underneath you notice there is a white square that indicates the ambient light level. There are three levels. There's white, gray, and black depending on the ambient light. So it's currently moving forward. Nothing really terribly exciting happening at this point. You notice that it's pretty slow, and that's actually intentional. I've created this a set of delays in the communication process because I've noted that the HC12 transceiver tends to be a little flaky, and there is also a timeout feature. As you can see here, it's timing out because of some dead spots apparently in the basement, so I'll keep retrying until it re-establishes communication with the robot. It could take a little bit of time here. Hopefully, yep, that worked. So it works, but yeah, as I said, it's a little flaky. So still going strong here, nothing in front of it that it can detect anyway. I imagine we're having communication problems from one room to the other. Imagine what what kind of headaches the operators of the Mars rovers have had over the years with communication. Still going. Nothing exciting to date. Oh, the light level has changed a little bit. It's getting a little darker. I think it's getting close to the couch here. More communication troubles. But it recovers fairly nicely. And once it moves from the trouble spot, it usually goes fine. Oh, it found an obstacle. So I was going to try to maneuver around it so it'll back up and try to turn to the right. If that's not possible, it will turn to the left instead. There it goes, turn to the right. Now we'll test. Every time it moves, it will test for three things: ambient light, motion in front of the robot, and obstacles. And will issue the appropriate warnings depending on what happens. Oh, there's another obstacle here. So it's going to back up again. And it's going to change direction. There we are. Let's see if we can find out where it's at. So it's moving back. Oh, it detected motion, my movements. Alright, I'm clearing. Don't get mad. Alright, it doesn't like me, so I'm gonna go ahead and get back. Now, sometimes what happens is temperature variations in the basement, if the vents are going, will cause issues. Oh, it's going home. So what's happening here is that I programmed it to go home once it executes about 15 steps of motion or so. And this is just for demonstration purposes. So right now it's not going to do anything. It will follow essentially the path that it used before. It will not try to explore new path. That will accelerate the process, so it won't be checking for obstacles or anything like that. However, if for any reason it can't find a proper path, it will start exploring again. Once it reaches home, which is this last square here, we'll go and check the final position. Alright, there it is, it's at home. So let's go see where it's at. Oh, and there it is. So we started just about here and facing this way, and so it came back really close to its original position. Now you notice it's not really straight. It seems to be actually moving sideways, and the reason for that is the Hero Jr. is equipped with a very primitive end of travel mechanism for the turn wheel, and these consist basically of two leaf springs, which you have to bend one way or the other in order to adjust for linear motion. I have yet to be able to get this robot to go in a straight line no matter what I do, and this is particularly true on an uneven surface like an uneven carpet here. It does better on hardwood floors or cement floors, but definitely not very good on carpets. Nonetheless, it does demonstrate the feature here that it is able to come back to where it started. That's basically it for this project. It's not so much different from your run-of-the-mill Roomba, except obviously far less sophisticated, but in my view a hell of a lot more interesting than a Roomba. Well, I hope you enjoyed this video, and thank you for watching.